Hello friends, in this video we are going to discuss about the frequency shifting property of Laplace transform, which is also known as shifting in S domain. According to this property, for any continuous time signal xt, if the Laplace transform of xt is x of s with the region of convergence equal to R, then the Laplace transform of e to the power s0 t xt will be x of s minus s0 with the region of convergence being R plus real of s0. Therefore, it can be seen that by the application of frequency shifting property, the region of convergence does not change, it merely shifts by an amount which is equal to real of s0. During the course of this lecture, we are going to verify the frequency shifting property, and with the help of a numerical example, we are going to see how this property can be applied in order to solve numerical problems during the exams. So let's get on with it. In order to verify this frequency shifting property, we are going to apply the basic definition of Laplace transform. So from the definition of Laplace transform, the Laplace of the function e to the power s0 t xt can be written as integration minus infinity to plus infinity e to the power s0 t xt into e to the power minus st dt. This can be rewritten as Laplace of e to the power s0 t xt equal to integration minus infinity to plus infinity xt into e to the power minus s minus s0 t dt. Let us call it equation 1. Now from the definition of Laplace transform, equation 1 represents x s minus s0. Therefore, Laplace of e to the power s0 t xt will be x of s minus s0. This is the frequency shifting property of Laplace transform. Hence, we can conclude that the frequency shifting property of Laplace transform has been verified. Now, with the help of a few numerical examples, it can be applied. For this purpose, let us consider one numerical example. Find the Laplace transform of the function xt equal to e to the power 2t ut, where ut is the unit step function. Now, how this problem can be solved? We know that from the table of standard Laplace transform pairs, Laplace of unit step function ut is nothing but 1 by s. Next, we are going to apply the frequency shifting property. See, here the value of s0 is equal to 2 because the factor that is provided, that is e to the power 2t. Let us call it x of s. So, according to frequency shifting property S0 equal to 2, and hence Laplace of xt will be x of s minus 2, that is 1 by s minus 2. So that is how, without performing any complex integration, simply by the application of the frequency shifting property, Laplace transform of this type of function can be obtained. Let us now see whether the rule of ROC can be verified. As I said earlier, that ROC remains the same, merely it suffers an amount of shift that is equal to real of S0. Let's see. When we are talking about the ROC of this function 1 by s, in this case the region of convergence or the ROC is real of s greater than 0, and for 1 by s minus 2 the ROC is real of s greater than 2. So clearly, if we compare the two ROCs, it can be quite clear that the ROC has suffered a shift, and the amount of shift is equal to real of S0. Hence, with the help of this example, not only we learned how to apply the frequency shifting property, but also we verified that the claim that I made about the ROC, that it merely suffers an amount of shift which is equal to real of S0, that is also being verified. So thank you for your patience. If you really like this video, then please subscribe the channel. More and more such videos will be coming so that it can be beneficial to all of you. Thank you.